The Webb telescope is so far out that it's picking up light that's been traveling for over 13 billion years. Since the universe has been growing, this light has stretched out from the most distant places. Because of this, we're basically looking back in time almost to the Big Bang. It's mind-blowing to think how vast the universe is, but everything started from a single point, the singularity. This is how people interpret the Big Bang idea anyway. The James Webb Space Telescope, JWST, has spotted some weird stuff about how the universe started and grew, making us scratch our heads. Brian Cox, the famous physicist, says that the JWST's crazy discoveries might totally change how we get the universe. So, let's jump in and look at these cool new space finds that could change what we know. The James Webb Space Telescope, named after James E. Webb, a big shot at NASA, is a modern marvel of space exploration. It's a huge step up from the Hubble Space Telescope because of a team effort by NASA, the European Space Agency, and the Canadian Space Agency. And it's way better than the Hubble. It uses the newest tech and is made to check out the universe in crazy detail. Unlike the Hubble, the JWST takes super clear pics of faraway objects in space, mostly using infrared light. This is cool because it can see through space dust and grab images of things that used to be hidden. It's got a giant 6.5mm main mirror made of 18 hexagonal pieces. It's also super far away, about 1.5 million kilometers from Earth, at a spot named L2. It circles the Sun with Earth, so it always has a good view of space. When it's looking into the faraway corners of space, it's like traveling through a lot of light years in time. The JWST uses infrared stuff to watch space happenings from billions of years ago. Because the universe is expanding, the light from these objects gets stretched out redshift, moving from colors we can see to infrared. Luckily, the JWST can spot infrared light from super faraway objects, letting scientists study how stars are born, watch galaxies grow, and check out the air around planets outside our solar system, exoplanets. One of the latest discoveries is finding tons of galaxies at the edge of what we can see. This is making people scratch their heads about how things started because it goes against what we thought. This is making us rethink our basic ideas about the cosmos. To get a base point of reference, let's take a quick peek at the past of space trips. Old groups like the Greeks and Chinese started the show by watching planets move. Newton's laws in the 1600s provided a way to think about space travel. In the mid-1900s, Edwin Hubble, a big, influential person who studied space, made some crazy space discoveries. His views showed that faraway nebulas were lone galaxies way beyond the Milky Way, changing what we knew about how big the universe is and how it's growing. Hubble showed that galaxies were moving away faster if they were further away, also proving that the universe is getting bigger. Then World War II happened, which marked the start of the space race with the Soviet Union. Sputnik in 1957 was the first man-made satellite in the sky. Yuri Gagarin's orbital flight in 1961 and the Apollo 11 moon landing in 1969 were huge wins for space tech. Fast-tracked to 1990, and we launched the Hubble Space Telescope, which gave us crazy clear and cool shots of space. Going from watching the skies way back when to making the James Webb Space Telescope is cool proof of us improving how we think about what makes up and surrounds the universe. It showed how big space is and switch up many core ideas in space from the old days. Think about the Hubble finding the famous Pillars of Creation picture in the Eagle Nebula, which showed a star area in some big towers of gas and space dust. Another win was the Hubble Deep Field, catching thousands of galaxies in what looked like just empty space. The Hubble also went deep into the air around planets beyond our solar system, finding stuff like water and organic stuff on faraway planets, hinting that there could be spots where life exists outside of our solar system. After the closest observed supernova ever, SN 1987A, came along, it shined a light on the life of stars. All of this made the Hubble Space Telescope a big must-have in modern times, with the world in awe of its finds. Its follower, the James Webb Space Telescope, was sent to build on the tech grown and found out the how-tos from a model of what forms how we now think of the universe origins, which right now is seen as the universe beginning about 13.8 billion years ago. It started crazy hot and dense as being a single point, growing out quickly and causing matter, power, and basic forces. As the universe grew, it cooled down, causing atoms, stars, galaxies, and the varied patterns seen now. The Big Bang idea also makes clear the cosmic microwave backlight, many light element levels, and the big large type shape structures in the universe. Even though many know it, the Big Bang idea hit problems at the start. Alternative options like the steady-stage idea planned a universe without a specific start, and worries of support that first space growth and the strange space stuff showed itself. Most of these blocks were dealt with over time, and the finding of the cosmic microwave background rays in 1965 got on board with the Big Bang Theory predictions. Space trips to the sky like COBE and WMAP with growing tech winds helped the thought and its views be supported in greater amount more. The James Webb Space Telescope, which is filled with up-to-date infrared tools that could look through space dust, grabbing oldest light power in the universe and seeing what formed right after the Big Bang. Its infrared powers let it look at star-forming areas and also areas where stars are raised, hidden from eye-catching telescopes. Infrared light that has longer wavelengths is able to punch through space dust, getting past a limit set by the Hubble Space Telescope. The James Webb Space Telescope could then watch cooler space life which majorly throws out infrared light, making it key for learning other facts with odd areas like exoplanets and dim stars. Because space bodies going away and going further stretch the light waves, which is known as a red shift, the James Webb Space Telescope has the right powers to catch that and learn how this happens. Space events like black hole or even a new star's birth are largely given out in infrared powers, which pushes even the telescope skills. The James Webb Space Telescope builds on ion telescopes like the Hubble by getting and having the skills required to get infrared power, allowing it to better the view and dig more to space history, helping show off what things make up our origin. It's allowed to see more of the universe more than ever. The James Webb Space Telescope has been our way to see space growing from the early parts of itself, and recently made an odd show-out point which might call for reconsideration on the space model. We have also ran across a big group of other galaxies at the view of what we could say is the universe's edge. These early stars came to be a few 100 million years past the Big Bang around morning of the universe, but in a puzzle it's not known how a group could form so soon. This point may have us second-guess how we viewed how space grows and what happens in space. Learning space galaxies is a key tool to learning other origin key points to the building blocks of space. It lets us know planets rise. These studies add to basic key puzzles of space, which includes how its and its pieces all make up and change the universe. Hubble had limits for its time, like its lack to punching space dust, seeing the early stars from billions of years. Older telescopes have eyeballs of visible eye and ultraviolet to watch, making it hard to learn the early space era. The James Webb Space Telescope wins from its predecessors by watching star stuff, making sure, like the space bodies from the Big Bang, are accounted for. The James Webb Telescope is even given a clarity in detail to the study of how the origins of space go over. Start results from the James Webb Telescope has sent ripples the way the models of space. Its detailed data has caused scientists to double-guess the hows and whys of building a cosmos which builds space itself. Differences between theories have led to scientists asking questions over time and finding new methods, which James Webb Telescope may hold the key to finding it. James Webb Space Telescope has shown a ton of galaxies than we thought were in the early part of the space era, which means it's getting added to with new patterns. It shows the assumption that stars will grow at a slow stage. The finding of a giant mass of galaxies have a shock from how space should be shown. We need to have a group meeting to think about it, making us grow on our thought that the cosmos is crazy. These points open new thought ways to explore, like a riddle. The existence of a lot galaxies is hard to prove, making scientists add more to the models to explain in the basic principles of space building should be there. In other words, all it showed has told scientists to think over again on the idea of the universe. But to that day, all that may know to say is that there is much more to see and study to prove it is such a new space study. Basic looks open thought ideas to show, for example, the qualities or building blocks can be shown across the galaxies. It may show it building blocks as showing changing ideas. To say the idea giant life is real needs a careful eye of understanding. We may do just that with spectroscopy. It needs the process of catching light given or used by objects in space. It helps show chemical makeup as well as temp and movement across the worlds. A James Webb has even helped show a clear change with ideas of space, as with the first point of the space worlds were simple with basic help from hydrogen, but after spectroscopy the galaxy had a whole different change, which shows there is different parts we may should have heard about. We may even see what composes stars. These thoughts that are simple from Hubble may show how and why space is made together for what it is today. The James Webb Telescope lives on as growing ways to see and understand, even the hard-to-reach spots from the space we have always loved. This way we may find chemical ways to keep our planets like us, and maybe there may be even a plan to live on a planet close to us.